Okay, everyone, let's begin. So what have we done in integration? We started with this, the idea of integration, that it's the opposite of differentiation, reverse differentiation, right? We looked at this power rule that basically told us how to integrate functions. If you had x raised to power something, that's how we would integrate that. And then we generalized that to this rule, that if we have ax plus b whole raised to power n, how do you integrate that? Add 1 to the power, divide by that new power, and also divide by the derivative of what is inside the power. This is the rule that we did with some examples, and there's the part inside the power, the base of the power. We said it had to be linear. If it was not linear, we could not use this rule. We would have to expand it first and then integrate it. That's what we discussed. We talked about some applications of integration after that, how to find the equation of a curve using the derivative. So basically you integrate, have a plus c, then you find the value of c using the point given in the question. And then you just write down the equation of the curve, right? That's what we did. And then there were some other applications of integration using integration with limits. So basically you can use integration to find areas between curves and x-axis, area between graphs and y-axis, volume of revolution about x-axis, volume of revolution about y-axis. We did all of this, right? These are the formulas that we have. Now in volume, let me see. Yeah, so we discussed this. So we have these formulas for area and volume. You need to memorize these. They are not given in the formula sheet. You will need to remember them. Okay. So area between a graph and x-axis, that's given by integral of y with respect to x. Limits are values of x here, and y needs to be the subject. Area of a graph with y-axis. This is x dy. Limits are values of y here. X needs to be the subject in this case. Then volume of revolution. Y square needs to be the subject. The formula is pi into integral of y square with respect to x. And then volume of revolution about y-axis. In that case, x squared needs to be the subject of the function that you have. You first need to make that subject, and limits are values of y. These are 4 formulas that we used. And then if we had to find area between 2 graphs, we said we would find the area between the upper graph and the x-axis and subtract from that the area between the lower graph and the x-axis. Similarly, for volume of revolution, we said we could find the volume of revolution of one graph and subtract from that the other one. That will give us the volume of revolution when the area between 2 graphs is rotated about an axis. Okay, so these are all the concepts that we have done until now. There's one small thing that is left. I would want to start today's class with that, and then we would have a look at the questions that you have from the worksheet. So there's just this very small concept that we still need to discuss. Let's talk about that first. And that is improper integrals. Improper integrals. Now, what is this about? There are multiple types of improper integrals. In our syllabus, we only have one type. And that particular type is when you have infinity as one of the limits. Okay, so when you have infinity as one of the limits in an integral, that is what we would call an improper integral. Okay, now let me give you an example of that. Let's say you have a function like this. Let's say you have this function y equals 3 over x squared, right? This is a function that we have. Now, what does the graph of this function look like? You've done graphs like these in O levels. How would you draw a graph of a function like this? You would just take some values of x, have the corresponding values of y, plot them on x and y axes, and that's going to give you some points. You can join these points and draw a graph. Using that, I'll tell you the graph of this function looks something like this. There are 2 parts of this graph. One is going to be here and the other is going to be here. Okay, so it looks something like this. Now, let's say if we are interested in the area between this graph and x-axis on the right side. So we are ignoring the left part of the graph. We are just focusing on the part that is on the right side here, on the positive side of x-axis. Let's say we want to find the area that looks like this from this point. Let's call this point something. Let's say this point is when x equals 1. This is the value of x is 1 here. If the value of x is 1 here, what would be the value of y? The value of y, according to this function, would be 3, right? So this is a point that I have on the graph. And what I want to find out is, I want to find the area under the graph to the right of x equals 1. So basically all of this region. I want to find the area of all of this region. Now, it's a graph that makes an asymptote on this side. So basically, this graph is going to go like this. It's going to keep getting closer and closer to the x-axis, but never actually touch it. So the graph goes like this on the right side. Okay, remember the graph of tan function that you have done in trigonometry that also used to make asymptotes like this, right? Although that was a vertical asymptote, in this case we have a horizontal asymptote. The idea is that the curve just keeps going on the right side like this, but never actually touches the x-axis. It's the same thing that's happening on the y-axis here as well, on the vertical axis as well. This graph is going to go like this on this side, or like this on this side, right? We are interested in all of this region. We want to find the area of this region. That's what the problem is. Okay. So the function is y equals 3 over x squared. And we are interested in all of this area. Now, let me just make some space here. This is the area that we want to find out. Now, how would you do that? How would you describe this area, first of all? This is area between the graph and x-axis, right? This is area between this graph that we've drawn and x-axis. How do you find area between a graph and x-axis? This is the formula that we use for that. The formula looks like this. Ax equals integral of y with respect to x, right? That's what the formula looks like. Limits are values of x, right? So we have some limits of x here from x equals a to x equals b, let's say. Let's input values in this formula. Ax equals integral of y. What's the function y? The function y is 3 over x squared. In power form, it would look like this: 3x raised to power negative 2. Okay, we want to integrate it. Now, what about the limits? What are the limits going to be? So we know that the lower limit is 1. What about the upper limit? Well, there's no upper limit, right? Because on the right side, there is no end point. The graph is just going on the right side like this, and we want to find all of this area. Now, by just looking at this area, you might think that this area is infinite, right? Because this curve keeps going on like this, okay? And you have all of this area to find out. So just by looking at it, looks like the area between the graph and x-axis should be infinite. But let's actually try calculating that and see what that gives us. So we have 3x raised to power negative 2. That's the function. Limits are from 1 to what's the maximum value? There's no maximum value. We can say the limits are from 1 to infinity. So the upper limit, we could say, is infinity. All right. That's what the integral looks like. Now, how do you evaluate this integral? That's what you want to do here. So this is what improper integrals are. Let me write that down here. What are improper integrals? Improper integrals are those integrals for our purposes here, as we are only doing one type of improper integrals. We're doing the type in which the limits are, one of the limits is basically infinity. So when one of the limits is infinite. Now it could be the upper limit infinity, as in the upper limit could be positive infinity, like in this case, or the lower limit could be negative infinity, right? Both those cases could be there. That's what we are going to be calling improper integrals. Now, how do you evaluate this? How do you find this area? Just like you do it normally, integrate the function, input the limits. What's the integral of this? 3x raised to power minus 1. How do you integrate that? 3 remains as it is. Add 1 to the power. So minus 2 plus 1, that's going to be minus 1 divided by minus 1. What are the limits? Limits are from 1 to infinity. Okay, and then what do you get? You get ax equals minus 3 over x. When you simplify this thing, that leaves you with minus 3 over x. And inside, you can say, outside, you can say the limits are from 1 to infinity. So you've integrated the function, and now you have the limits 1 to infinity. All you need to do now is input these limits in this integral. Now, how would you do that? One of the limits is infinity. Now, we can just say, let's input infinity into this function. Now, infinity is not a number, so you will realize this later in your maybe first course at university, that it's not a very good idea to input infinity in a function like this. There's a proper way of doing that. We basically use the concepts of limits, and that's another kind of limit actually, to evaluate expressions like these. But for our purposes in A levels, it is okay to input infinity like this. So just input infinity in place of x like this. Okay, and I'll explain you how to calculate this in a moment. So just input infinity in place of x like this. All right. That gives us minus 3 over infinity when we input the upper limit. Subtract from that the case when you input x equals 1, minus 3 over 1. How do you evaluate this now? That's the question, right? Minus 3 over 1, that's minus 3. That's easy to figure out. What about this? Minus 3 over infinity. What is this number going to be? How do you think about this? So you have minus 3 divided by infinity. Infinity basically means an extremely large number, right? Extremely large number is something that you can't even think about. It's extremely large. When the denominator becomes extremely large like this, what is going to happen to this whole fraction? Think about this. So on your calculator, for instance, try inputting 100 in place of infinity, although that's a pretty small number, but just for understanding the pattern, input 100 in case of, instead of infinity. What do you get from that? You get minus 0.03. Now 100 is a pretty small number. Now try increasing this number and see what is happening to this fraction. So try, for instance, minus 3 over 10 raised to power 5. What does that give you? That will give you minus 0.00003, right? 4 zeros and then a 3. What if it was what if it was even larger? Maybe 10 raised to power 100. Try putting that on your calculator and see what that gives you. You'll get minus 3 into 10 raised to power minus 100. Can you think about what this number would look like in decimals? Minus 0.0000 and then like 99 zeros and then a 3 somewhere. So that's an extremely small number. So basically what happens is when you divide something by infinity like this whole fraction basically becomes 0. This whole thing goes to 0. How do you figure that out? One way to do this is that you just input this fraction in your calculator. If you find it hard to think of it logically, just put this fraction on your calculator, replace infinity with an extremely large number. So just like I did there, minus 3 over 10 raised to power 100. And your calculator will give an extremely small value, and that will make you realize, okay, this means this is basically approaching 0. So this basically approaches 0. And what are we left with then? Minus into minus 3. And the result turns out to be 0 plus 3, and that is 3 squared units. And that means this area that we had here, this shaded area, this is actually a finite area. And the value of this area is 3 squared units. It's not infinite. It's a finite area. So this is how you can input limits, input infinity as one of the limits in integration, right? So if you had to find this area, the upper limit we would say is infinity. And then when we input infinity here, if it comes in the denominator, whatever that fraction is, that is going to become 0. And we get the result from this. Does this make sense to everyone?
Yes, sir.
Sir,
Yes?
sir, what if the infinity is being multiplied?
Yeah, so that's a good question. What if infinity was being multiplied? What happens in that case? So let's take another scenario. Let's say we wanted to find the area between the graph and y-axis now. Okay, let's say we were looking for that area between the graph and y-axis, and let's say we were looking for maybe if x equals 0.5, that gives us 0.25, 3 over 0.25, that's going to be 12. Let's say we have some number here, which is 12. Okay, and now we're interested in finding this region. Area between the graph and y-axis here. What would that be? That will be all of this region. And so now we want to find this area. Okay. Now, how do you find area between graph and y-axis? What's the formula for that? Ay is integral of x with respect to y. Let's see what this turns out to be. So area between graph and y-axis, that's what you want to calculate now. This is given by integral of x with respect to y. Limits are going to be values of y here. Y equals a to y equals b. And the function was y equals 3 over x squared. Right? Yeah, that's what the function is. Now, how do you find this area? You first need to make x the subject, right? In order to input values in this formula, you need to make x the subject. Let's make x the subject and see what that gives you. X squared equals 3 over y. Okay, now you take square root on both sides. When you take square root on both sides, that's going to give you x equals plus minus 3 over y whole raised to the power 1 over 2. Right? That's what you get when you make x the subject. Now, this plus minus will cause some problems. If we look at this function, this is what we're getting, x equals plus minus 3 over y whole raised to the power 1 over 2. If you look at the function, there are two parts of this function. One part is to the right of the y-axis, and the other part is to the left of the x-axis. Basically, the right part is when x equals plus 3 over y whole raised to the power 1 over 2, and the left part is when x equals minus 3 over y whole raised to the power 1 over 2. Right? Why? Because on the right side, x is positive, and on the left side, x is negative. So we are looking for the right part, right? So we will only consider the positive part here. That means the function that we're talking about is this. With the plus sign, x equals 3 over y whole raised to the power 1 over 2. This is what the function is. Now let's input this in the formula. Let's see what we get from that. Ay equals integral of 3 over y whole raised to the power 1 over 2. How can we write this? We can say this is, okay, let's write it like this first. 3 over y whole raised to the power 1 over 2 with respect to y. Limits, what are the limits? Limits are going to be values of y now. What are the values of y? From 12 to infinity. The lower limit is 12 and the upper limit is infinity. So now we have 12 to infinity here. Okay, this is what we want to evaluate. Now let's try doing this. How do you integrate this function first of all? Let me write it in this form first. Let's bring y to the denominator. If y comes to the denominator, it's going to be 3y raised to power minus 1, right? And then whole raised to power 1 over 2. How do you integrate this now? You can split the power like this. You can say it's 3 raised to power 1 over 2, right? Because it's multiplying here. So 3 raised to power 1 over 2 and y raised to power minus 1 over 2, right? Since 3 raised to power 1 over 2 is a constant, we can just write that outside the integral if we want, and that's perfectly okay. Inside, we're just left with y raised to power minus 1 over 2 with respect to y. Okay, now this integration has become a bit complicated. That was not the point. But anyway, this is what we have. We have 3 raised to power 1 over 2 outside, and inside we have y raised to power minus 1 over 2. How do we integrate this now? 3 raised to power 1 over 2 outside remains as it is. What's the integration of this? Y raised to power 1 over 2 divided by 1 over 2. That's the integration. Limits are from 12 to infinity. Now this 2 will come to the numerator, and the integral turns out to be 2y raised to power 1 over 2. Right? This 2 will go to the numerator like this. Limits are from 12 to infinity. Now let's try inputting the limits. You have 3 raised to power 1 over 2 outside. Inside, when you input the limits, you have 2 into infinity raised to power 1 over 2 minus 2 into 12 raised to power 1 over 2. This is the area that you get from this. Now, 3 raised to power 1 over 2 is a positive number. The problem is we have 2 times infinity raised to power 1 over 2. Now, infinity is an extremely large number. Even if you take square root of infinity, that is still infinity, right? So basically, this area that we have, this goes to infinity. This area is infinite. So this area does not have a finite value. So that yellow region does have a finite value. When infinity comes in the denominator, like in the first case, the area would have a finite value, like in this case. In the second case, in the blue area, the area between the graph and y-axis, that area is not finite. That does not have a finite value. That is why infinity here is coming in the numerator, and the result basically is going to be infinity. That means that area does not have any finite value, so we can't calculate that, right? That's what would happen. We don't have any value for that area. Okay. Now, since we don't have a finite value of this area, you will generally not be tested in this. At least until now, they have not tested this, that the area turns out to be infinite in some case. But this can happen when the area is finite with an infinite limit. This is what does come in the exam. This hasn't happened until now, but if it happens, you will just say the area is infinite. There's no finite value of the area. Is that okay? Is that okay to everyone?
Sir,
Yes, sir.
sir, won't we write infinity minus 2 into 12 raised to power 1 over 2, or we will simply write infinity?
Infinity is not a number. Infinity is basically a concept that infinity, that it's an extremely large number. So extremely large numbers, think about something extremely large. So maybe something like this, 10 raised to power trillions, right? Extremely large number. Now, from this extremely large number, so infinity is even bigger than this, right? So this is just a large number that we can think of at this point. Even if you were to subtract 2 into 12 raised to power 1 over 2, is it really going to make any difference? It's still an extremely large number. So we just say it's infinity, right? So infinity basically means that it's an extremely large number that we can't really write a value for. Okay.
Okay, sir.
So the area is infinite here. That's the result that we got. So this first thing is tested. So you need to make sure that you understand this. When infinity comes in the denominator like that, that fraction becomes 0. Okay. All right. So that's one last thing that we wanted to discuss. Now let's have a look at some questions from the worksheet. Now it's not tested that often, so you might not find many questions on this in past papers, maybe just a couple. But it's still important because it's part of your syllabus, so you have to know this. So in case it comes, you would know how to deal with it, okay? All right, so now let's have a look at some questions from the worksheet. Again, please write down the questions that you have in the chat box so we could discuss some of them. So I have 4 questions in the chat box until now, 9, 17, 41, and 52. If you have any other questions apart from that, please write them in the chat box as well. Okay, now let me have a look at these questions quickly. I could decide the order in which we're going to do them. Just to make save a bit of time as well, can you also specify which question parts you have problems in? So maybe the easier parts we could perhaps skip. So can you also specify the particular parts that you're having problems in so we can do more questions in less time? So all of you who have asked questions in the chat box, please specify the particular parts as well, in case it's not the whole question. Okay. Rijal, part 3 of this question is basically coordinate geometry. Remember that formula? And it's not actually integration. Part 3 is you need to find the angle between two tangents. You would have the gradients of the two tangents, right? Gradient of the curve at P and the gradient of the curve at Q. Once you have those two gradients, you just need to find the gradients between lines having those gradients. These are two lines. You can find the gradients at each of these 2 points. Let's call the first one M1. Let's call the second one M2. And remember that formula that we did in coordinate geometry? Tan theta is equal to M1 minus M2 divided by 1 plus M1 times M2. Right? You could use that formula. Just input the values of M1 and M2, the gradient of the tangent at P, which is going to be the gradient of the curve at P, and the gradient of the curve at Q. Call one of them M1, the other one M2. Just input values, you'll find that that gradient. Okay, so that's basically coordinate geometry. You can do that, and you're saying the first 2 parts you were able to do. Okay, that's good. What about 41 and 52? Yeah, have a look at them as well. Okay, there's only one part. That means you are just part this whole question. We'll have a look at this 52. Which part of this? Okay, this looks like a good question, Lisa. We'll have a look at this 52 as well. And then we have 21. Okay, this does not look that complicated. It's just the area between two graphs. All right. Okay, so let's have a look at some of these questions then. We're going to start with question number 21, right? Let's start with this one. And then we'll go in order. The next one is 41 and then 52. Question number 21 from the worksheet. 9, Hazim is saying he has figured it out. If anyone else has a problem with 9, you can let me know. Question number 21. Okay. So it says the diagram shows the curve y equals x minus 2 whole squared and the line y plus 2x equals 7, which intersect at points A and B. Find the area of the shaded region. Now, how would you describe this shaded area? This is the area between two graphs. You have a straight line and you have a curve. This is the area between these two functions. All right. So you'll just find the area between the upper graph and the x-axis and subtract from that the area between the lower graph and the x-axis. That's all that you've got to do. But the problem is you don't have any limits. So you need to figure out what this point here is on the x-axis. And you also need to figure out what this point here is on the x-axis. The x coordinates of A and B, you will need to find them first. It's an 8-mark question, so they basically require you to think of all of this yourself. Otherwise, they often break such questions down into parts, but in this case, they haven't done that. They want you to figure this whole process out yourself. So in order to find that area, you need limits, right? What are the limits? The x coordinate of A and the x coordinate of B. So we first need to figure out what the x coordinates of A and B are. Now, A and B are points of intersection of these two graphs. How do you find points of intersection? Points of intersection are found by solving equations simultaneously. So that's what we do. We have one equation, which is y equals x minus 2 whole squared, and the other one is y plus 2x equals 7. We can just solve these two equations simultaneously to find the values of x here and here. Okay, so what do? We can make x the subject from the second equation as well. That gives y the subject, sorry, from the second equation as well. And that gives us y equals 7 minus 2x. Now we have y as the subject in both of them. We can equate them. So that gives us x minus 2 whole squared equal to 7 minus 2x. Let's solve this equation. We can expand the left side. That gives us x squared minus 2 into x into 2. That's minus 4x plus 4. Minus 7 plus 2x equals 0. And the equation becomes x squared minus 2x minus 3 equals 0. Okay. Now let's solve this equation. Can we factorize this? We can. It becomes x squared minus 3x plus x minus 3 equals 0. That gives us two factors, x minus 3 and x plus 1, which means x either equals 3 or x equals minus 1. So the 2 points of intersection that we have, their x coordinates are minus 1 and 3. You can see A is the point on the left side, B is the point on the right side. So the left one should be negative 1. So we say this is A and this is the x coordinate of B. Now, we were only looking for the x coordinates. We have found them. We don't need the y coordinates, right? The limits that we have to use are values of x. So now we can say this is negative 1 and this is 3. So now you just need to integrate both functions, input limits, find the area of the graph of the upper graph with the x-axis, subtract from that the area between the lower graph and the x-axis. Let's try that. So we have two graphs here. We have an upper graph and a lower graph. Let's do that separately. Okay, so the upper graph is this one, y plus 2x equals 7. What's the formula that we have for area between a graph and x-axis? The formula is this. Let's write that down. This is the formula. Integral of y with respect to x, limits are values of x, x equals a to x equals b. The first function is y plus 2x equals 7. Now, in order to find the area, we need y the subject. So we first make y the subject, and that gives us y equal to 7 minus 2x. And now just input values in the formula. We say area between this upper graph and x-axis, that's going to be 7 minus 2x. Integral of this with limits minus 1 to plus 3. Okay. Now you can just evaluate this and see what that turns out to be. Integral of 7 minus 2x, integration of 7 is 7x minus 2x squared divided by 2, input limits, minus 1 to 3. 2 and 2 get cancelled, and we are left with 7 into 3 minus 3 squared. That's what you get when you input 3. Subtract from this the case when you input -1, so that's 7 into -1 minus -1 whole squared. What does that give you? 21 minus 9 minus -7 minus 1. Okay, and that is 12 minus -8, so that's 12 plus 8, and that's 20. This is the area between the upper graph and x-axis. Similarly, you find the area between the lower graph and x-axis. What's the lower graph? The other function is y equals x minus 2 whole squared. Do the same thing with this. Find the area between this graph and x-axis. X minus 2 whole squared. Limits are from -1 to 3. You need to integrate it and input the limits. Now, the base of this power is linear. That means we can use the power rule on this directly. We don't have to expand it. We can just use the power rule directly. X minus 2 whole raised to power 3 divided by 3 and divided by the derivative of what is inside the brackets, that is 1. That's the integral. Input limits from -1 to 3. Let's see what we get from that. When we input 3, that gives us 3 minus 2 whole raised to power 3 divided by 3. Subtract from this -1 minus 2 whole raised to power 3 divided by 3. Okay, and that turns out to be 1 over 3 minus -3 whole cube. That is going to be -27 divided by 3. And that's 1 over 3 plus 27 over 3. I'm getting 28 over 3 from this. So can you please check the calculation as well in case there are any careless errors? So this is what we are getting, 1 over 3 plus 27 over 3, that's 28 over 3. So we have the area between the upper graph and x-axis, and we have the area between the lower graph and x-axis. What's the shaded area now? Just find their difference. 20 minus 28 over 3, that is 60 minus 28, that's 32 over 3. In decimals, that's going to be 10.67. That's the shaded region that we were looking at. Is that correct?
Sir, can you please zoom out the question?
Yes, sir.
Working.
Sorry?
The answer working. The answer.
Please download the OneNote app on your phones and along with OneDrive app. And you will have access to all of these notes there once you open the link given in the WhatsApp group's description. That will be extremely helpful for your last minute revision now. As you approach your exams, you need to keep revising everything again and again. There's so many details that we have discussed in every single topic. If you have not been taking notes down yourself in detail, make sure that you have access to the OneNote, this whole OneNote notebook. You have the link for that in the WhatsApp group's description. You need to download OneNote app and OneDrive app, both of these apps on your phone, log into them using the same account, and then click on that link that will open in the OneNote app. Okay, and you'll have access to all of these notebooks that we have here, all of these sections that we have here, by all the chapters. Okay, and that will be extremely helpful for revision later on.
Sir, can you?
Yeah.
Sir, can you tell the y coordinate of x when is x is -1?
We don't need that. You're saying y coordinate of a when x is -1. Why do we need that?
Okay.
Okay. We only need the x and x limits, right? We don't need the y and the limits of y here. That's not required. Okay, that's the shaded area that we have. All right, good. Let's have a look at the next one now. That was question number 21 from the worksheet. Now the next one is question number 41. Okay. The diagram shows the region enclosed by the curve y equals 6 over 2x minus 3, the x-axis, and the lines x equals 2 and x equals 3. Find in terms of y the volume obtained when this region is rotated 360 degrees about the x-axis. What's the area that they're talking about? They're talking about this enclosed region, right? This is the area. How do you describe this area? This is the area between the curve and x-axis. When this area between the curve and x-axis is rotated about x-axis, what's the volume obtained? Now, it's just the standard result that you get from the volume of revolution formula. The area between the curve and x-axis that is rotated about the x-axis. What's the volume formula for a situation like this? Vx, volume of revolution about x-axis, that's given by pi into integral of y squared with respect to x. You just have to use this formula. Okay. Limits are from 2 to 3. These are the limits of x here. X equals a to x equals b. Limits are 2 to 3 here. Now, let's see how we're going to input values in this formula. We have y equals 6 over 2x minus 3. Now, remember, we need y squared to be the subject. So we first can square this thing. And that gives us 6 squared divided by 2x minus 3 whole squared. Now, for integration, we need the x terms to be in the numerator. So we can say y squared equals 6 squared, which is 36, into 2x minus 3 whole raised to power negative 2. That's what y squared is. Now put this here. Volume of revolution formula, it looks like this, pi into integral of 36 into 2x minus 3 whole raised to power minus 2 with respect to x. Limits are from 2 to 3. And now I just need to integrate this input limits. 36 is a constant. You can write that outside if you want. It's multiplying. It's not going to change. It will remain as it is. So you can write that outside as well with pi. So we have 36 pi into integral of this thing. Now it's a linear expression inside. So we can just use the power rule. You can say 2x minus 3 whole raised to power minus 2 plus 1, that's minus 1, divided by minus 1, and also divide by the derivative of this thing. What's the derivative of 2x minus 3? That's 2. And that is going to give you the result when you input limits from 2 to 3 inside this. 36 pi multiplied by, let me actually simplify this first before we input limits. So this negative sign, we can write that here, minus into 2x minus 3 whole raised to power minus 1. Actually write that in the denominator as well. Minus 1 over 2 into 2x minus 3 whole raised to power 1. Right? That's what the function inside is. It helps to simplify it first before you input limits, because dealing with negative powers becomes a bit complicated sometimes. I just took that numerator with negative power to the denominator, and I got something like this. Now you can input the limits, and that's 36 pi. Now, if you are comfortable using a calculator with limits and fraction button, you can input that here as well, and that's perfectly okay. As long as you're sure that you will not be doing careless errors, you can do that. Now, let's input these values. So first of all, we have minus 1 over 2 into 2 times 3 minus 3. Subtract from that minus 1 over 2 into 2 times 2 minus 3. Okay, now 36 pi remains outside. It's multiplying with the whole thing, remember? Now, what do we have inside here? Minus 1 over 2 into 6 minus 3. That's 6 plus 6. Minus 1 over 6, right? Minus minus 1 over 2, right? That's 36 pi into minus 1 over 6 plus 1 over 2. I can put this whole thing on a calculator and see what you get. In terms of pi, remember, the question asks you to find the result in terms of pi. So 36 into this thing, what do you get? 3 over 6, 2 over 6, and that's 1 over 3, 1 over 3 into 36, 12 pi, right? Yeah. So that's the area that you have. A volume that you have, volume of revolution about x-axis. That's all that you have to do. Just apply the formula, input limits. There was no complication here as such. Is that okay?
Yes, sir.
All right, so that was question number 41. Let's have a look at the next one now. That's question number 52. Okay, let's try this now. Question number 52 from the worksheet. Please make sure that you're doing revision alongside of the previous topics. Otherwise, it's very common that you just start forgetting stuff. And then you'll start panicking because the time left is not that much now. You need to make sure that you're revising alongside. Question number 52. Okay, so it says the diagram shows part of the curve y equals x minus 2 whole raised to power 4 and the point A 1, 1 on the curve. The tangent at A cuts the x-axis at B and the normal at A cuts the y-axis at C. Find the coordinates of B and C. Okay, so we have a curve. This is the curve that we have. There's a point A on the curve. The tangent at A, so if you were to draw a tangent at A, this tangent cuts the x-axis at this point B, and there's a normal to the curve at the same point. It cuts the y-axis at C. So basically, B and C are x and y intercepts of the tangent and the normal respectively. We need to find the coordinates of B and C. Now, how do you find the coordinates of B and C? For that, you would have to find the equations of tangents of the tangent and the normal first of all, because once you have the equation of the tangent, you can just find the x-intercept of that, and that will give you this point. Once you have the equation of the normal, you can just find the y-intercept of that. That will give you this point C. So basically, the main problem here is finding the equation of the tangent and the equation of the normal, right? So that's the main part of this question. So let's find the equation of the tangent and normal at this particular point. I just have to follow that process. Remember what we did in differentiation. We have this curve y equals x minus 2 whole raised to power 4. Tangent and normal, they are straight lines. How do you find equations of straight lines? You need two things, a point and gradient, right? We have a point already. We just need to find the gradients of the tangent and the normal. How do you find the gradients of the tangent and the normal? You do that using differentiation. So first of all, you have to find the derivative of this. That will give you the gradient of the curve at that point. What's the derivative of this? Multiply by the power 4 into x minus 2, subtract 1 from the power, multiply with the derivative of what is inside. The derivative of x is 1. This is what the derivative turns out to be, 4 into x minus 2 whole cube. Now, we want the derivative at this particular point. At that particular point, the value of x is 1. So we input x equals 1 there. And that gives us dy over dx equal to 4 into 1 minus 2 whole cube, which is minus 4. This is the gradient of the curve at A. at the point A, the gradient of the curve is -4. So that's what we have figured out. Now, can we write down the equation of the tangent and the normal? Let's start with the tangent first of all. We have the normal as well. So we have a point A, which had coordinates 1 and 1. That's common between the tangent and the normal, right? What about the gradient of the tangent? Gradient of tangent is the same as the gradient of the curve at that point. That's -4. And the gradient of the normal is negative reciprocal of that. So change the sign, take reciprocal, that's going to be 1/4. Now just use the standard form y minus y1 equals m into x minus x1 to write down both equations. The equation of tangent will turn out to be y minus 1 equals -4 into x minus 1. You can simplify that to get -4x plus 4 plus 1, y equals -4x plus 5. That's the equation of the tangent. And the equation of the normal, that's y minus 1 equals 1/4 into x minus 1. And that gives you y equals 1/4x minus 1/4 plus 1. And that's going to be y equals 1/4x plus 3/4. We have the equation of the tangent and the equation of the normal. Now, what were we looking for? We were looking for the x-intercept of the tangent. So we have the equation of the tangent now. This is the equation of the tangent. For finding the x-intercept of this equation, what do? We put y equal to 0. To find x-intercept. When we input y equal to 0, that gives us 0 equal to -4x plus 5. And that's going to give us x equals 5/4. X equals 5/4. In decimals, that will be 1.25. Or you can just leave it like this, and that's perfectly okay. That's your choice. 1.25 is an exact decimal, as in it doesn't have infinity many decimal places, so it's okay to write it as decimal as well. Fraction is also fine, both of them work. So what's the x? What are the coordinates of the point B then? B was the x-intercept, right? So coordinates of B are 1.25 and 0. Now similarly, C is the y-intercept of the normal. Now, what about the y-intercept of the normal? In y equals mx plus c form, we know that this constant is the y-intercept. You could try inputting x equal to 0. When you input x equal to 0, you're left with 3/4. So that's the y-intercept. And that means the coordinates of C, therefore, are 0 and 3/4. 3/4 is 0.75. Again, you could write this as a decimal or a fraction. Both of them are okay. So we have the coordinates of B and C. That's what we were looking for in the first part. Any problem with this? No?
No problem, sir.
Okay, so that's the first part, right? Now in the second part, it says find the distance AC, giving an answer in the form square root of A over B, where A and B are integers. Okay, that's relatively straightforward, it seems. You just have to find distance between 2 points. Point A is 1 and 1, and point C is 0 and 0.75. Since you want an exact answer, let's actually write it as a fraction. We say this is 0 and 3/4. So you see, they're basically asking us to give an answer in this form, square root of A over B. That means you want an exact answer. You cannot use decimals. So for that, it's better to write it as a fraction. We have these 2 points. We need to find the distance AC. How do you find distance AC? Distance formula is x2 minus x1 whole squared plus y2 minus y1 whole squared, and then square root of that whole thing. So we can say this is x1, this is y1, we can say this is x2, this is y2. Square root of x2 minus x1, so that's 0 minus 1 whole squared, plus y2 minus y1, that's 3 over 4 minus 1 whole squared. Let's simplify this. 0 minus 1 whole squared, that's minus 1 whole squared, which is just 1, plus 3 over 4 minus 1, that's minus 1 over 4 whole squared, and then square root of that. And that gives us 1 plus 1 over 16, right? Yeah. And that turns out to be square root of 17 over 16. Now 16 is a perfect square, so we could write this as square root of 17 divided by 4. That's the distance AC. That's what we were looking for. Okay. Now in the first two parts, there was no integration, right? The first part was differentiation. And the second part was coordinate geometry, just finding distance between 2 points. Let's look at the last part now. In the last part, it says find the area of the shaded region. Now this looks slightly complicated. We need to find the area of this shaded region. Now, how would you describe this shaded area? How would you find this area?
Coordinate
Yes,
x
Abdurrahman.
coordinate of the tangent, x coordinate of the tangent, and the x coordinate of the graph. So now I could. So you can first find out the x coordinate of the tangent, then we can find out the x coordinate of the
Okay, so we already know. Okay, so we already know this point is 1, right? And we also know this point. We have found this. This was 1.25. This is 1.25 or 5 over 4. So what do we do now? What other point are we looking for?
curve.
The x-intercept of the curve. So that's basically this point here somewhere. How do you find the x-intercept of the curve? Let's figure that out. You put y equal to 0, right? Let's try doing that. Y equal to 0, that gives you x minus 2 whole raised to power 4. That means x minus 2 equals 0 and x equals 2. So this point is 2. So we know these points now. We know the x coordinates of all of these important points. Now, how would you describe this shaded area? How would you find this area? Now that we know these points. So just tell me in words, first of all, what are we going to calculate? Is it just the area between the graph and x-axis? Do we need to subtract something from that, add something to that? What do you think?
Sir, we can integrate the
Okay, so forget about
tangent.
integration. Forget about integration. Just tell me which area is going to be added or subtracted from what area. So just describe it in words, first of all. Then we can think of how to calculate it. But how do you describe this area?
Curve minus the area of tangent.
Okay, so if you were to describe this area, you could say it's the area between the curve and the x-axis. That will be all of this area. And subtract from that the area between this straight line, which is the tangent, and the x-axis. So from the area under the curve, we just have to subtract the area under the triangle. Okay, and I think that's what Abdullah was saying as well. He was just telling us about the calculation, how to calculate it. So we will integrate the curve, put limits 1 to 2 in that, integrate the line, put limits 1 to 1.25 in that. Now it's not really necessary to do integration on the tangent, by the way. You could just find this area using area of triangle as well if you want, right? This is a triangle. So you could find the area between the graph, between the curve and x-axis, Subtract from that the area of this triangle, right? This triangle has a height of 1 and a base of 1.2, a base of 0.25. We could find the area of this curve directly like this. So without integration,
0.125.
yeah, so the area would be 0.125, half into base into height. You just subtract that from the area under the curve, right? So you can do it either way. You can do integration for that as well, and that's perfectly okay. That will give you the same result as well. So let's calculate this now. Part 2, sorry, or part 3, sorry. So we have two functions again. We have an upper function and we have a lower function. Upper function is the graph. Upper graph is, the curve is the upper graph in this case. However, notice that the limits are different. Limits are not the same, right? For the curve, limits are from 1 to 2. For the triangle, the limits are going to be from 1 to 1.25. Okay, so let's start with the curve. The curve is y equals x minus 2 whole raised to power 4. Y equals x minus 2 whole raised to power 4. Let's find the area under the graph first of all. Under the curve first of all. That's x minus 2 whole raised to power 4 limits 1 to 2. Right? That's pretty straightforward. Just integrate it. X minus 2 whole raised to power 5 divided by 5 into 1 if you want, right? Because the derivative of x minus 2 is 1. Input limits from 1 to 2. When we input 2, that gives us x minus 2 whole raised to power 5. That's just, x minus 2 whole raised to power 5. That is going to give us 0. 2 minus 2 whole raised to power 5 over 5. Subtract from this 1 minus 2 whole raised to power 5 divided by 5. That gives us 0 minus 1 over 5. So the area turns out to be 1 over 5 or 0.2. That's the area between the curve and x-axis. Then we have the lower graph. Now, you could do that using integration if you wanted, or you can just find the area of the triangle. That's perfectly okay as well. Let's use area of triangle here. Half into base into height. Base of this triangle is 0.25, height is 1, right? So this side is 1, base is 0.25. So you can say it's half into 0.25 into 1, and that gives us 0.125. So what's the shaded area then? Just the difference of these two values. Shaded area is 0.2 minus 0.125, which is 0.075. That's the shaded area. Make sense? Any issues with this?
Sir.
Yeah.
Sir, I'm confused how, why did you take the triangle as upper and the triangle as lower graph?
This is the curve. This is the line. How can we find the shaded area? The shaded area can be found by subtracting the area under the curve, subtracting from the area under the curve, the area under the line. So in this region, in all of this region, what is the upper graph? The upper graph is this curve. And what's the lower graph? The lower graph is this line. So the upper graph is curve, the lower graph is line. Isn't that quite visible from the graph? Or maybe you're just confused, why are we using area of triangle formula? You could use integration there if you want. As in, the point is just to find that area, right? The point is just to find this area of triangle, right? Now, you could do that using integration, and that's perfectly okay. the equation of the tangent is what we have found here. Y equals minus 4x plus 5. You could do that. Instead of using area of triangle, you could use that function here. Let me just add that here. So you could say y equals minus 4x plus 5. Right, that's the function. You could find the area between the tangent and the x-axis. That would be minus 4x plus 5 whole raised to power, whole integrated with respect to x, limits 1 to 2. What's the integral? Minus 4x squared divided by 2, that's going to be minus 2x squared plus 5x. Input limits from 1 to 2. When you input 2, you get minus 2 into 2 squared plus 5 into 2. Subtract from that minus 2 into 1 squared plus 5 into 1, which turns out to be minus 8 plus 10, which is 2 minus 2 minus 3. No, this is something wrong here. Minus 4x plus 5 minus 2x squared plus 5x limits. Okay, so I'm sorry, I've input the wrong limits here. Limits are from 1 to 1.25. Okay, limits for the line were actually 1 to 1.25. Let me correct them here. Limits were from 1 to 1.25. Actually put those limits here. And that gives us minus 2 into 1.25 whole squared plus 5 into 1.25. Can somebody tell me what this number is? What this result is? The first bracket, what does this evaluate to?
25/8.
25/8. Subtract from that the second bracket, which is 3. And that results in 1/8, which is 0.125. And that gives you the same area. Now, we are just saying, why go through all of this trouble of integrating and then inputting these limits and calculating all of that, when you can just see the area that we want at the end, the area under that line is basically the area of this triangle. And area of triangle can easily be found using half into base into height. So we could just use that formula directly instead of using integration here. Make sense?
Yes, sir.
So it's just an alternative method for that. If you want to still use integration, that's perfectly okay. You can do that. Where the area of using the formula for area of triangle just makes it a lot simpler. You can just do it in one single step. All right. Any other questions from the worksheet? Any other problems, anyone? No?
No, sir.
Okay, so there are a couple of questions that I want to discuss apart from the ones that you've asked, and then we end. So maybe 15 more minutes almost, and then we end. Now, first of all, this is an important one from the worksheet. Question number 64. Question number 64 from the worksheet. It's an 8-mark question. Let's try this. It says the equation of a curve is such that d square y over dx square, that means the second derivative, is 2x minus 1. Given that the curve has a minimum point at 3 minus 10, find the coordinates of the maximum point. So we are given the second derivative of a curve, right? We're given that d square y over dx square, that is 2x minus 1. And we're given a minimum point that's 3 and minus 10. We need to find the coordinates of the maximum point. So what do you want at the end? You basically want the coordinates of the maximum point, right? That's what the end goal is. Now, how do you find maximum point? How do you find turning point of a function? You find the derivative of that, put that equal to 0, right? That's how you find the maximum point. So at the maximum point, you basically need to use this dy over dx equal to 0. All right. Now let's see how we can find that derivative. First of all, what do we have to start from? We have the second derivative given, d square y over dx squared, that is equal to 2x minus 1, right? That's the second derivative. How do you go from the second derivative to the first derivative? Remember, if you have a function y and you want to go to dy over dx and then d square y over dx squared, what do you do for that? You differentiate. As you go from left to right, you have to differentiate. When you differentiate y, the derivative of y is dy over dx, and then the derivative of dy over dx is d square y over dx square. If you have to go in the opposite direction, what do you have to do in that case? You have to integrate. So if you want to go from dy over dx to y, you have to integrate. And similarly, if you have to go from d square y over dx squared to dy over dx, you have to integrate for that as well. So from right to left, you have to integrate. So we have the second derivative given. We want to put the first derivative equal to 0. So the first thing is we say, let's integrate it to get dy over dx. Let's integrate this and see what that gives us. Dy over dx, that equals 2x squared over 2 minus x. That's the integration. Are we missing something? Plus c. Whenever we integrate, we have a plus c with that. Okay. So dy over dx turns out to be x squared minus x plus c. Now, we have done many questions in which we were finding areas and volumes. In that case, we were using integration with limits, and we were not putting any plus c there because it would have gotten cancelled out anyway. But when you're doing all of that, don't forget, when you don't have limits, you always have to put plus c, right? So plus c always has to be there. Don't forget about this. So this is dy over dx. X squared minus x plus c. We have to put this equal to 0, and that will give us the x coordinate of the turning point. But now the problem is we have a c here. How do you find the value of c? How do you find the value of c? Do we have any information given in the question that can help us find this value?
Sir, we can put c as minus 10.
C is minus 10? How? Why?
Sir, because c is the y-intercept, and in the
C is
above
y-intercept of what? Y-intercept of what? This is dy over dx. This is not a curve. And this is also not giving you the y-intercept of the curve. It's the minimum point of the curve. It's not y-intercept of the curve. It's just the y coordinate of one particular point on the curve. We can't just assume that the value of c is negative 10. Okay, let's actually think about it. So we have the minimum point. The minimum point of this function is given to be 3 and minus 10. This is a minimum point of this function that we've got. Okay, that's what we are given. Now, if this is a minimum point, what that means is this minimum point has an x coordinate of 3 and y coordinate of -10. So at this particular point, x is 3 and y is -10. So we have one value of x for which we know the corresponding value of y. But the problem is we don't have x and y here. We have x and dy over dx here. Now, since it's a minimum point, at the minimum point is also a turning point. At the minimum point, what should be the derivative? Derivative dy over dx, that should actually be 0. Right? At the turning point, dy over dx has to be 0. So we basically know a point at which x equals 3, y equals -10, and dy over dx equal to 0. So in order to find the value of c here, what we can do is, let's input x equal to 3, because we know when x equals 3, since it's a minimum point, dy over dx is supposed to be 0. And that will help us find the value of c. So put dy over dx equal to 0. When x equals 3, that gives us 3 squared minus 3 plus c, and the value of c turns out to be, so we have 9 minus 3 plus c equals 0. C turns out to be -6. And that means we have this derivative dy over dx equal to x squared minus x minus 6. So we have found dy over dx now. We have found the value of c that we had there. Make sense? So since we are given a minimum point, we know minimum point is also a turning point. It's a stationary point. So at that point, dy over dx is supposed to be 0. So that tells us when x equals 3, y equals -10, and dy over dx equals 0. So that's the information that the question is basically giving us. All right. Now we have dy over dx equal, the value of dy over dx, the expression for dy over dx. What are we looking for? We are looking for the maximum point. That's what we're looking to find. How do you find the maximum point? For maximum point as well, dy over dx has to be equal to 0. So now we put dy over dx equal to 0. Now that we have the value of c, we put this equal to 0, put dy over dx equal to 0. And that gives us 0 equals x squared minus x minus 6. You can solve this equation, see what that gives you. X squared minus, can we factorize this? Yes, x squared minus 3x plus 2x minus 6 equals 0. And that leaves us with x into x minus 3 plus 2 into x minus 3. We get two factors, x plus 2 and x minus 3, which means x either equals -2 or x equals +3. These are two x values at which we would have turning points. Now, the minimum point already is known, that's 3 and -10. So we have one x value that is 3. We know that this is for the minimum point. That's not what we're looking for. We already know the minimum point. This is the x coordinate of the maximum point. Right? If one point is minimum, the other is going to be maximum. You can't have two maximums and no minimum. So it's going to be a cubic function that's going to look like this, basically. Coefficient of x cube is going to be positive. So the graph is actually going to look like this. Now, you don't necessarily have to know that, but just for understanding, this is what the function would look like, right? It would have one maximum point. This would be a maximum, and this would be a minimum. Okay, so we have the minimum point given. The minimum point is 3 and -10. This is what the question already tells us. What we have found is the x coordinate of the maximum point. Now, the question asked us for the coordinates of the maximum point, not just the x coordinate, we also need the y coordinate. How do you find the y coordinate of this now? Once we have the x coordinate, we put that value of x back in the original function to find the corresponding value for y. But the problem is we don't have the original function now. We had the second derivative. We use the second derivative to find the first derivative, but we don't have the original function y equal to something. We don't have that. We have to find this as well. How do you do that now? You have dy over dx. You integrate that again to find the original function. Let's do that now. So we have dy over dx, and that is x squared minus x minus 6. You'll have to integrate this again, and that gives you x cubed over 3 minus x squared over 2 minus 6x. But again, you're integrating. You have a plus c here. Now, this c is not necessarily going to be the same as this c, right? So if you want, you can call this c1 and the next one c2. Or you can just understand that this c is not the same as the previous one. It's some other constant, okay? So now you have this function. Now you also need to find the value of this c. How do you do that? You have one variable y here, one x. You know a point on this function already. This minimum point that you have, at this minimum point, x equals 3 and y equals negative 10. You can input this point there now. Input x equals 3 and y equals negative 10. Let's do that. We say, let's input x equals 3 and y equals negative 10. So we're putting that point here. What does that give us? That gives us minus 10 equals 3 cubed over 3 minus 3 squared over 2 minus 6 into 3 plus c. Can somebody tell me what the value of c turns out to be from this? What is c?
Plus 7 over 2.
7 over 2. Thank you. So that's the value of c that we have, which means the function now becomes y equals x cubed over 3 minus x squared over 2 minus 6x plus 7 over 2. That's the function that we have. Now we had the x coordinate of the maximum point. We need to find the corresponding y coordinate of that maximum point. So for that, what we do is we put x equals negative 2 in this, and that results in y equals minus 2 whole cube divided by 3 minus minus 2 whole squared. Always put negative numbers inside brackets, otherwise your result is not going to be correct. So this is minus 2 whole squared, so it's going to become positive when you take a square. Over 2 minus 6 into minus 2 plus 7 over 2. What's the value of y that we get from this? Minus 8 over 3 minus 4 over 2
27
plus
over
12.
2.
Sorry?
27 over 2.
27 over 2. Okay. I hope that working is correct, but that's the logic. As in, can somebody confirm this as well? If there's no careless error, can you check the marking scheme for the final result? Because it was a long working, there might be some plus minus error somewhere. So if this working is correct, as in if there's no careless error, what we get at the end is that the maximum point is supposed to be negative 2 and 27 over 2.
Sir, I'm
All
getting
right.
89 over 6.
89 over 6? From this?
Yes, sir.
Actually, that might be correct because here the LCM is supposed to be 6, right? 3 and 2. But it might be simplified as well. Can somebody else confirm this as well? Okay, C seems to be correct. What do you get when you input x equals negative
Yes,
2?
sir. I got 89 over 6 as well. I read it.
89
I
over
got
6.
89 over 6.
Okay, so that's 89 over 6. Can you confirm this from the marking scheme as well now? Just to make sure that we've not done any other careless errors. Has anyone checked?
Sir, what question number is this?
64. Okay, so I'm just checking and it does not seem to be correct. Okay, so there's some error somewhere. Okay, it's correct until this point. Is the value of C correct? Can you confirm this as well? The value of C? Okay, that's actually correct, 7 over 2.
Yeah, the value of C is 3 1 over 2. So it's 7 over 2.
Yeah, so that's correct. But the final result seems to be different. Okay, I think I need to bring my own calculator just to confirm what we are doing here. X cube over 3 minus x over 2 minus 6x plus 7 over 2. Yeah, so marking scheme says 65 over 6, right? So let me just check this. Minus 2 whole cube divided by 3 minus 4 divided by 2 plus 12 plus 7 divided by 2. What are you guys doing? It's 65 over 6. It's not 89 over 6. How are you inputting this in your calculator? I'm getting 65 over 6. This is 65 over 6. When you input this in your calculator, the result is 65 over 6. How are you inputting this? Make sure that you're using brackets correctly. Write this exactly as it looks like in your calculator. You're most likely missing some bracket, not using fractions correctly. Let me see what you are doing. How can you get 89 from that?
Sir, I didn't took bracket on -2 whole square.
Yeah, so of course that will be a problem, right? Because that will make it positive. So make sure that you're putting everything in the calculator directly. You lose useless marks in this case, as in why would you do all that effort and end up losing 2 marks just for this silly mistake? When you input this in your calculator, make sure everything is written correctly like this inside brackets, using brackets properly. All right. So the result is 65 over 6 on this. Are you getting this now on your calculator?
Yes, sir.
Yes, sir.
Okay. All right, good. So we are running out of time now. There was one other question I wanted to have a look at. Okay, so let me quickly just look at a couple of parts of this question and then we end for today. question number 9 that Hazim asked about earlier, I actually looked at that. And one part of that looked slightly complicated. Last part is straightforward. Let's just have a look at the first 3 parts quickly. So it's actually not really integration, it's more differentiation than integration, the first 3 parts. But let's have a look at this because it looks like a good question. So first 3 parts, they're actually differentiation, but let's do them quickly. And then we end for today. Tomorrow, we will continue with functions. Those of you who missed the class in the afternoon, the recording is uploaded. Please make sure to watch that recording before tomorrow's class. We did some very important concepts today, and we will be referring to those concepts tomorrow. So if you missed today's class and you come to tomorrow's class without having watched the recording, you'll be having trouble understanding the concepts. And what we did today was extremely important. Range of functions, how to find range of functions, especially quadratic functions. There were a number of examples that we did for that. It's extremely important to understand that concept. The recording is uploaded. Please make sure to watch it before tomorrow's class at 2:15 p.m. or so. 2:10. We'll try to start early maybe. But make sure to watch the recording if you missed today's class. Okay. Now the diagram shows the curve y equals this, where k is a constant. The curve has a minimum point on the x-axis. This is a minimum point. It says find the value of k. Now, how do you find the value of k? It's a minimum point. It's a 4-mark question. So we have y equals x cubed minus 3x squared minus 9x plus k. Now, first of all, it's the x-intercept of the curve. We know that this point is the x-intercept. We want k. For k, what we can do is we can find this turning point. And once we have that turning point, we could input that in the function to find the value of k. Yeah. So this is the minimum point. We know the y coordinate of the minimum point already. The y coordinate of the minimum point is 0. How do you find the x coordinate? You can just find the derivative of this, dy over dx. That will eliminate k from this equation. So that gives you 3x squared minus 6x minus 9. That's what the derivative becomes. You can find the turning point by putting dy over dx equal to 0. Let's put that equal to 0, and that gives us 3x squared minus 6x minus 9 equal to 0. We could simplify this equation to write it as x squared minus 2x minus 3 equals 0. Can we factorize this now? We can. It becomes x squared minus 3x plus x minus 3 equals 0. We get 2 factors from this, x minus 3 and x plus 1. X either equals 3 or x equals minus 1. So that means we have the turning points of this graph when x equals 3 and x equals minus 1. You can look at the graph. X equals 3 and x equals minus 1. The positive one is 3, so this is 3. This one is 3. The negative one is negative 1, so that means this point here, this will have minus 1 as its x coordinate. Now, we don't need that for now, but maybe later. And the next part, we have found these 2 values, minus 1 and 3. So now, we know that this point is 3 and 0. This point lies on the curve. We can find the value of k now. How can you find the value of k? Since we know the function looks like this. Y equals x cubed minus 3x squared minus 9x plus k. All we have to do is put x equals 3 and y equals 0 in this. What does that give us? 0 equals 3 cubed minus 3 into 3 squared minus 9 into 3 plus k. And the first 2 terms are going to get cancelled, and we're left with k equals 27. That's the value of k that we get in the first part. Okay, so that's the first thing that you have to do here. Find the value of k, that's 27. Okay, let's look at the second part now. The second part says, find the coordinates of the maximum point on the curve. Now we already know the x coordinate of the maximum point, right? We found that in the first part. What about the corresponding y coordinate? We can just put that in the equation. That's y equal to, the equation is y equals x cubed minus 3x squared minus 9x plus 27, right? That's the equation of the curve that we've got. Okay. Now, what about the coordinates of the maximum point? Just input x equals -1 in the function, and that will give you the corresponding y coordinate. So we put x equals -1, and that gives us y equals -1 whole raised to the power 3 into -1 whole squared minus 9 into -1 plus 27. What's the value of y that we get? -1 minus 3 is -4 plus 9 is 5 plus 27. Is it 32? Is y 32?
Yes, sir.
Right? So y is 32. That means the maximum point is -1 and 32. That's the maximum point that we were looking for. Now let's look at part 3. Part 3 says, state the set of values of x for which this is a decreasing function of x. Now, what's a decreasing function? A decreasing function is where the gradient is negative, right? A decreasing function is where gradient is negative. In differentiation, we looked at this. We used to put derivative less than 0, right? But in this case, we have the graph given, so we can see from the graph. On the left side of this maximum point, the function is increasing, the gradient is positive. And then the function starts going downwards. So here the gradient is negative. So this is the decreasing part of the graph. And then on the right side, the function starts increasing again. We are looking for the region in which the graph is decreasing. So where is the graph decreasing? It's decreasing in the middle part. What are the values of x for which this is a decreasing function? Between -1 and 3. So what would you write here? You would say x is between -1 and +3. This is the set of values of x for which it's a decreasing function. Does that make sense? X between -1 and 3. Okay. Now the last part says find the area of the shaded region. That's pretty straightforward. You just integrated input limits from 0 to 3. You can do that. That completes the topic. So you've done enough practice on this. Now, make sure that you attempt the rest of the questions if you haven't attempted all of them. But you've done the more difficult ones of these problems. In fact, I'll just show you this one question before we end. We will not be doing it, but so it should be here. You should try this question as well. It's a good one from a recent paper. I actually gave this as a test to the class. So you can have a look at this. What I'll do is I'll just copy this there maybe. Do I have the marking scheme for this? Let me check. Okay, no. So what you can do is you can just take a snapshot of this. So this question. Yeah, I'll just copy this there. In the OneNote notebook. So try this question as well. I'm adding it at the end of the notebook. I'll show this to you in a moment. This was the first page and this is the second page. So it's there in your OneNote notebook now. If you want to take a picture, you can also do that. I'll show that to you now. This is the first part of the question. We have this diagram that shows this curve. You have to find the shaded area, right? You can find the area by using area between graph and x-axis or area between graph and y-axis. You can describe it both ways. You can use any of those two formulas here. They will work. Okay. That's the first part. You can try that. The second part requires you to find the volume obtained when the region is rotated 360 degrees about the x-axis. For this, you will be using this formula, pi y squared with respect to x, right? With limits of x. Since you want to rotate about x-axis, y squared needs to be the subject. Now, if y squared is the subject, this is what the function is, 1 over 2 into x raised to the power 4 minus 1. Right, that's what the function is given. When you take y squared, that's going to be 1 over 4 into x raised to the power 4 minus 1 whole squared. Now, you cannot integrate it directly. Why can't you integrate it directly? Because the part inside the power is not linear. So in order to integrate it, you would first need to expand it to x raised to the power 8 minus 2x raised to the power 4 plus 1. And then you can input this in the formula and integrate and input the limits, right? So that's something that you need to understand here. Then the next part basically asks you to find the volume obtained when the shaded region is rotated 360 degrees about the y-axis. Now, the function was y equals 1 over 2 into x raised to the power 4 minus 1. Right, that's what the function was. Now, if you have to rotate it about the y-axis, the formula for that is pi into integral of x squared with respect to y, and limits are values of y. Now, if you have to use this formula, you need to make x squared the subject here. So that will become 2y equals x raised to the power 4 minus 1, and that will give you x raised to the power 4 equal to 2y plus 1. Then it takes square root on both sides, and that will give you x squared equals 2y plus 1 whole raised to the power 1 over 2. This is what you would input here. Input the limits of the y-axis in this case. The limits will be minus 1 to 0 in this case. And you can just integrate, input those limits, and find the volume obtained. Okay, it's a good one. Especially the second part, you need to understand if you have a square like this, you can't integrate it directly. You have to first expand it and then integrate it. All right, I hope that makes sense. I will see you again tomorrow, inshallah, in which we will continue with the function concepts, inshallah. All right, that's it. Allah Hafiz, everyone. See you tomorrow.
Allah Hafiz, sir.
Allah Hafiz. Allah Hafiz.